lesson 2. And in this lesson, I want you to be able to effectively add, subtract, multiply, and divide rational expressions. Rational means we have a problem that has fractions. Expressions means there is no equal sign. So we're not solving for x. We're not trying to figure out what x is. We're just trying to rewrite this in the simplest form. So I'm going to, without talking too much, I'm going to factor both the left and right denominators. Three times -2, 3 and -2 combined to give us 1. Okay, so combination multiplies and combines. And remember, if the leading coefficient is anything other than 1, we need to put it underneath. And I'm going to reduce it down to 1/2, then reduce it to 1/3. After I reduce it, we're still in fraction form. We push up 2x plus 1 and 3x minus 1. This is the factored form of this trinomial. Over here, we don't see a middle term. It's like here's the 1x. We don't see a middle term. So if this doesn't already, pop in your head how to factor this, but since there is no middle term, I can put a 0x. Looking for two numbers that multiply to equal -4, combined to equal 0. Remember, the leading coefficient is anything other than 1 needs to go underneath. I'm going to reduce and push up. So that's the initial work. I'm going to go back and I'm going to rewrite this, but I'm going to take out this part of the expression and this part of the expression. I'm going to replace it with the factored form. So it would be 2x plus 1 and 3x minus 1 and 2x plus 1 and 2x minus 1. Okay, so these two expressions are exactly the same. They're just in different forms. This is the factored form of the denominators. Now I'm going to focus on the denominators. We need to find a common denominator anytime we add or subtract. So they both have a 2x plus 1. The left side needs to have a 2x minus 1 attached to it. So I'm going to attach this factor 2x minus 1. I also am going to attach it to the top. I'll explain why in a little bit. Okay, this has a 3x minus 1. It's missing on the right, so I'm going to attach it to the right. And you may be wondering, why do you have to do the top and the bottom? Because we don't want to change the value of the fraction when we attach it. I'll give you an example. Everybody knows that 1/2 is equal to 0.5. They're equivalent, decimal form and fraction form. But watch, if I take that same fraction, I can multiply it by any number. If I multiply it on the bottom by, let's say, 3, as long as I also multiply on top by that same value, I have 3/6, which also equals 0.5. So when I take the denominator and I multiply it by the factor 2x minus 1, as long as I also multiply the numerator of that fraction by the same quantity, I haven't changed the value. Okay, so here we go. We have this at this point. I'm going to now write down what they have. Okay, take 5x times 2x to get 10x squared. 5x times -1 to equal -5x. 2 times 3x to equal 6x. 2 times -1 to equal -2. Combining the middles. And remember, we need to put this in simplest form. So if I stop now and it's not in simplified form, it would not be, I would not have effectively simplified the rational expression. So I need to look at the numerator and ask myself, can I go further? Give me 1 second. 10x squared plus 1x minus 2. 10 times negative 2 is negative 20. Do I know two numbers that multiply to equal negative 20 and combine to equal positive 1? 5 and negative 4. So x plus 5 and x minus 4. Take the 10 and put it underneath. And now reduce those fractions. And now again, we've reduced the fraction, push it up. 2x plus 1 and 5x minus 2. So I'm going to rewrite this, and now I have the numerator also in factored form. Sometimes the numerators can factor, sometimes they can't. When they can't, that's okay. You just leave it. If this wasn't factorable, I leave it just as is. So I have 2 factors on top and 3 factors on the bottom. A misconception is that students say, oh, can't I just take a 2x here and a 2x here, and I'm going to reduce it, and maybe there's a 2 here and a 2 here and reduce. Think of this as a family or a couple. They're in some type of have some type of a relationship. They have to go together. So this is the factor 2x plus 1. This is the factor 5x minus 2. They go together. So 2 unique factors on top and 3 unique factors on the bottom. The only way for us to simplify is if we see one factor on top that is exactly the same as a factor on the bottom. So when they divide, they don't just disappear magically. In fact, when you divide, they actually turn into a 1. It's a common misconception as well, as they think that they become a 0 or just disappear. So I have 1 times this quantity on top, and we don't have to put a 1 in front. We know 1 times something is not changing it. On the bottom, I have 2x minus 1 and 3x minus 1. Okay, this is fully simplified. Do not FOIL this out. This is the final answer.